Evaluate the integral from 0 to pi e to the x cos x dx. We will let u be one thing and dv be the other. Would you let u be the first one or the second one? Second one? Sure. For those of you who want to try the other way, try it. I'm not telling you that this is the right method. I'm just telling you that you may want to try it out with different methods. du equals negative sine x dx. And then when we integrate the other part, the integral of this will just be e to the x itself, which means when we use the formula for integration by parts, we will end up with u times v minus the integration of v times du. Negative sine x dx. Let me put the negative sign, the negative outside. So this is after one integration by parts. Does it look easier to work with now? Well, we turn cosine x into sine x. You want to do it the other way? Okay. Well, then let u be e to the x, and dv would then be cos x dx. Is that what you want to do now? Okay. Then du equals e to the x dx, and this becomes sine x. Yeah, it looks like they're pretty much the same, isn't it? It doesn't change. There are times when it doesn't matter. Yes, like this example here, it doesn't matter which one you go with, they will still end with the same result. And that's the time when you need to do it for one extra step. We will use another by parts. So, are we still going to go with the same substitution? Or this time you want to let u be this and dv be that? Once again, it doesn't matter, but you are going to see something very similar at the end. Now I'm going to try to be consistent, seeing how we let u be cosine x in my first by parts. I'm going to use sine x for now. I try to make it more be consistent, so that once we get to a certain point, you will be able to see something very similar to each other. They will be a little bit different. They will be a little bit out of sync. You will see what it means. Well, if you give it a try, you're going to see how they will look different. But for now, I'm going to try to be consistent. I will continue to use the trig function to be my u. And you will see why I want to do it that way. So for the first part, it will stay the same. And for the second part, this whole thing here, we need to proceed another integration by parts, giving us u times v minus the integral of v times du. Are you going to do it for one extra step? Identical to the first one, okay. Well, that's a very important observation here. If you were getting something that looked exactly the same as the question itself, what does it mean? Yeah, we can group the like terms together. Seeing how we are getting exactly the same thing here. When I bring it to the other side, group the like terms together, we will end up with 2 times the same integral. And that means the question itself, the integration of this will be the same as 1/2 of this cos x sin x. Well, of course, we still need to do the definite integral from 0 to pi. So we have e, substitute pi into it, cos pi, sin pi, minus same thing with x equals 0, cosine 0, sine 0. In this case, we will end up with e pi minus 1.